Okay, let's go back to this problem. Solve the simultaneous equations x squared minus 10x plus y squared equals to 25 and y minus x equals to 1. So we are given x squared minus 10x plus y squared equals to 25 and y minus x equals to 1. And we are required to determine the values of x and the values of y. Since we have x in this equation raised to a power of 2 and y raised to a power of 2, we at least expect to get two values of each. So let's call this equation 1 and this equation 2. Let's solve them simultaneously using substitution method. From equation 2, y minus x equals to 1. Let's make y the subject of the formula. This becomes y equals to 1 plus x. Let's substitute for y in equation 1. Substituting for y in equation 1. This will become x squared minus 10x plus, instead of y squared you will have 1 plus x but squared, which equals to 25. So this is the same as x squared minus 10x plus, let's expand this binomial using Pascal's triangle. From Pascal's triangle, if you have a plus b squared, to expand this binomial using Pascal's triangle, you first draw the Pascal's triangle, which is 1, 1, 1, 1, 2, and 1. These are the coefficients for a degree 2 exponent of a binomial. So this will equal to, for this coefficient 1, the first coefficient 1, the power of a will be raised to this exponent 2, but the power of b will be raised to 0. For the coefficient 2, to create the second term, start with the coefficient 2. The power of a from the preceding term reduces by 1, so this will become a to power 1, and the power of b from the preceding term increases by 1, so it will become b to power 1, plus, for this third and last coefficient, you have 1. The power of a reduces by 1 from the preceding term, so it will become a to power 0, whereas the power of b will increase by 1, so it will become b squared. So this is the same as a squared plus 2ab plus b squared. Let's do the same for this. So it will become 1 squared plus 2 into 1 into x plus x squared, which equals to 25. So this is the same as x squared minus 10x plus 1 squared is the same as 1 plus 2 times 1 times x the same as 2x plus x squared equals to 25. X squared plus x squared, we get 2x squared, in negative 10x plus 2x the same as negative 8x plus 1 equals to 25. But this is the same as 2x squared minus 8x plus 1 minus 25 equals to 0. This implies that we have 2x squared minus 8x, 1 minus 25 same as negative 24 equals to 0. But this is of the form ax squared plus bx plus c equals to 0. It is a quadratic equation, a degree 2 equation. We can as well reduce this equation by dividing through by 2. So if you divide this through by 2, it will become x squared minus 4x minus 12 equals to 0. This is the same equation as this. But let's proceed with this. Using quadratical bulldozer method, we will obtain the value of x from negative b plus or minus root of b squared minus 4ac all over 2a. But from the comparison of these two equations, a, the coefficient of x squared will be equal to 2, and the coefficient of x, which is b, will be equal to negative 8. whereas the coefficient of x to power 0, which is c, will be equal to negative 24. The same applies if we had used this, it will be 1, negative 4, and negative 12. We will obtain the same values. This implies that we have x equals to negative b, which is negative 8, plus or minus root of b, which is negative 8, but squared minus 4 into a, which is 2, times c, which is negative 24, all over 2 into a, which is 2. Let's use the calculator to obtain these values. So we go to mod, equation, degree 2, which is 3. The value of a is 2. The value of b is negative. It's negative 8. The value of c is negative 24. Negative 24. So the value of x1 equals to 6. And the value of x2 equals to negative 2. So either x, which is x1, equals to 6, or x, which is x2, equals to negative 2. We have x2 equals to negative 2 and x1 equals to 6. Let's use these values to obtain the values of y. From this equation, this y equals to 1 plus x. Let's call it equation 3. So from equation 3, y equals to 1 plus x. When x equals to 6, the corresponding value of y will be equal to 1 plus 6, which equals to 7. And when x equals to negative 2, the corresponding value of y will equal to 1 plus negative 2 equals to negative 1. Let's conclude. Therefore, when x equals to 6, the corresponding value of y will equal to 7. And when x equals to negative 2, the corresponding value of y will equal to negative 1. In ordered pair format, this is the same as 6, 7. It's in the form xy coordinate form. The same applies to this. Is the same as negative 2, negative 1. So this is the solution to our problem.